Welcome to today's lesson on slopes of parallel and perpendicular lines. Now up to now we've been looking at parallel and perpendicular lines in free-floating space, and we've been really concerned with the angles that are formed with parallel lines cut by a transversal. But today we're going to take those lines and we're going to anchor those lines on a coordinate plane. So we're going to have some x-axes and y-axes, and we're going to really look at slopes in terms of the algebraic approach. So I guess the first thing we ought to take a look at is what is slope. So slope, a good way to think about it, is basically the tilt of a line. It's how tilted a line is. And you know from algebra that we abbreviate slope using the letter m. And you also remember from algebra that we define slope as the rise over the run. And since the rise comes from the y-axis and the run, the horizontal amount, comes from the x-axis, we define this as the change in your y's over the change in your x's. So you just pick any y value, you subtract the other y value, and you do the same with their corresponding x values. So let's take a look at some examples, and I always like to start out with the pictures. So let's take a look here at some pictures. And these, by the way, correspond directly with the pictures in your notes. So the first four examples, we're finding the slope of each line. So if we look at this red line, we simply pick any 2 points, this one here and this one here, and we find the slope. Now we could go up and we could use this formula. We could identify the coordinates of these points and plug them into a formula. But since you have a picture, it's actually really easy to find the rise and the run. The rise, going from the first point on the left to the second point on the right, is up 2. So I could say that the slope here is up 2. And the run is, let's see, to the right, 1, 2, 3. So the slope here would be 2/3. Now, what if you picked 2 other points? Like what if I started here and I went down to that point? Would that give me a different slope? Well, if we look at it, if we start here and we go down, my rise is down, so it would be a -2. And my run would be to the left, 1, 2, 3. And of course, if we go to the left, that would be a -3. And isn't a negative divided by a negative still a positive? So it doesn't matter which 2 points you use. As long as you clean up or simplify your fraction, the slope's always the same. So when we come to number 2, you pick any 2 points, and it doesn't matter which 2. I mean, maybe we choose this point up here and this point here, and we count the rise, and that would be 1, 2, 3, 4, which is down 4, and the run, which is moving 1 to the right, so that would be right 1. And that gives me a slope of -4. So finding the slopes of lines is not super challenging at first because all we're doing is we're just counting. Now that's if you have a picture. But the next 2 examples, you have coordinates. So since there's no picture involved here, this would be a good chance for us to use our formulas. So remember, slope is the rise over the run. And so we're going to take our y values and subtract those. So maybe I take this first y value of 7, and I subtract this second y value of 2. And now you do the same with the corresponding x's. So since we started with the 7 first, I'll start with the -4 first, and I'll subtract this 6, this x value of 6. And so in the top, 7 minus 2, that's 5. And in the bottom, -4 minus 6 is -10. And when we clean that fraction up, we get a -1/2. A positive divided by a negative is a negative. Now, what if you want to argue? What if you chose the other y values to start with? So let's do that. Slope is the rise over the run. And if we chose, say, to start with the 2 first, then we'd have to do 2 minus 7. And in the bottom, to be consistent, we'd have to have the 6 minus a -4. Now, you remember from algebra, 2 negatives, when we add the opposite here, that becomes a positive. So in the top, we get a -5, and in the bottom, we get a 10. And since a negative divided by a positive is a negative, this still is negative 1/2. So it still works out. Now, why don't you try this last one yourself? Find the slope of a line passing through those points. You might pause the video, try it on your own on your guided notes, and see what you get. Welcome back. Hopefully you got the slope to be negative 1/3. And if you didn't, try it again and you'll get there. So now we've taken a look at slopes, so we know how to find slopes of lines. But let's take a look now at some special circumstances. So down at the bottom of your first page of guided notes, I ask you to fill in the blanks for the slopes of line A, line B, and line C. So why don't you pause now and see if you can fill in that whole bottom section. Welcome back. Hopefully you counted the slope of line A to be 2/3, up 2 to the right 3, and the slope of line B is also 2/3. But the slope of line C, notice it's going in a separate direction, and notice line C is steeper, so I'm expecting a larger number here. So it's negative because it's going in the opposite direction, and it's 3/2. It's a steeper slope. But what I'm concerned with are the terms we would use to describe these lines. And if you look at line A and line B, you'll notice that they are parallel to each other. And that shouldn't be a surprise since their slopes are the same. And remember, if the slope is the line's tilt, it just makes sense that those parallel lines would have to have the same slope. Their tilts would have to be the same. And if you look at the relationship between the blue line A and the green line C, that relationship is that they're perpendicular. And to show you, I have right here a square, and that's a right angle in that square. Well, if I take that square and I turn it so I line up one side perfectly with A, and I stick it right there in the corner, notice one side of the right angle is on A, one side of the right angle is on C, and so that means A and C form a right angle, and our fancy word for that is indeed perpendicular. So the big idea of the day, those of you filling out the guided notes, is parallel lines have the same slope. Perpendicular lines have what we call opposite, meaning if one's positive, the other one's negative, they're opposites. Reciprocal slopes. And the word reciprocal implies a flip is happening. So I think the best way is to look at an example. Suppose some random line L has a slope of -4/5. So there's some line out there, its slope is -4/5. We would know any line parallel to L would have a slope of, well, parallel lines have the same slope, so that would be -4/5. Any line perpendicular to L, remember our symbol for perpendicular, and it's like an upside down capital T, would have a slope of opposite reciprocal. Since L was negative, this slope would be positive, and reciprocal means you flip the number, 5/4. So let's take a look at some examples of how we might do these problems. So the first example here, find the slope of a line, a parallel line, and a perpendicular line. So the first example is we're going to take this point, point A, and we're going to find its slope. So let's just find the slope of A going straight up formula. M equals the rise over the run. And we know we're going to just plug some numbers in. So maybe I start with -7. So I'm going to put that -7, this y value right here, minus -1. Now watch how I handle the -1. Oh, ooh. Do you see how the negative for the 1 made that minus a positive? And in the bottom, if we have a -3 here, then we're going to subtract 5. And cleaning that up, in the top we get -6. In the bottom we get -8. And that, of course, is 3/4. So we know this slope is 3/4. And once we find the slope using our formula technique, we can find the parallel slope in mere seconds. We know parallel lines have the same slope. So 3/4, 3/4. And the perpendicular slope is just as easy. It is an opposite reciprocal. So since my original slope was positive, this is going to be negative, and we flip the number. Now why don't you pause the video and try problem B, and then come back. Hey, welcome to problem B. I'm going to go ahead and just reveal how I went through the mechanics and how I found this slope. And again, you just pick a y value. It doesn't matter which one, and you pick an x value. But it turns out this is the slope of the line, -1. The parallel slope, exact same, -1. And the perpendicular slope is you change the sign, so instead of negative, it's positive, and you flip it. Well, 1's kind of special because when you flip 1, you get, well, 1. And the last one is right here, and this one's a little tricky. So why don't you pause the video and see if you can find both the slope, the parallel slope, and the perpendicular slope. Well, welcome back. Here's what I did for this one. I found my slope. It's the rise over the run. And again, I plugged these numbers into this equation right here. And what I got in the top was a 0. And of course, 0 divided by any non-zero number is just 0. And so this slope is 0 and that slope 0. And if you remember from algebra, a line with a slope of 0 is just a horizontal line. Now, when you take a number like 0 over -4, that's 0. But when you find the reciprocal of that, when you put a -4 on top and a 0 on the bottom, ooh, that's the one thing in math you can't do, divide by 0. We say that's undefined. And if you remember back from algebra, that would be a vertical line. So that one was a tricky one. Hey, speaking of tricky, so the challenge here is we're now going to be given a slope. So this time I give you what the slope is. Then I give you a point, but I only give you part of a point. So we have to find the value, in this case, the x value of this missing point. And at first this might seem really intimidating, and your first guess might be, well, I'll just guess. And then if it's not right, I'll fix it. And although that works okay, these get pretty messy. So let's actually just approach this from a very logical standpoint, and that's that we have a formula. We know that the slope is the rise over the run. And I know the slope. I know the value of m. It's 3/4. And so what I can do is I can plug in the y's. In this case, maybe I start with a 4 minus, watch how I do this, -5 over smiley face, which is my unknown x value, minus, again, watch how this is done, -2. And of course, the two negatives make it a positive. And now it just becomes a basic algebra equation. So we can clean things up. 3/4 equals, well, we know 4 plus 5 is 9 over smiley face plus 2. And now one of our strategies that we learned in algebra last year is when you have a single fraction equal to a single fraction, you can cross multiply. And so when we do that, on the one side, we get 3 times the quantity of smiley face plus 2. And on the other side, we get 4 times 9, which is 36. And just walking through and distributing and solving this algebraic equation, we can eventually come up with our value for smiley face, which is 10. And although at first it seems intimidating, it really is just a matter of plug and chug. You just take your formula. Slope is the change in the y's over the change in the x's. You plug in your values and you let the algebra handle the work. Today is very much an algebra-based day. So we have a second problem here, and that's problem B. And I'd like you to take a minute and see if you can figure out the answer to problem B. Okay, so hopefully you did a very similar thing as you did up above. You set up the equation that the slope, 3/8, equals the change in y's, maybe you did smiley face minus 1, over the change in the x's, -3 minus 7, and you cleaned it up and cross-multiplied. One more example, and that's example C, so why don't you pause the video and see if you can get example C. There's the answer. So today's homework assignment is very much an algebra-based homework assignment where you find slopes. You have a formula or you have a graph. and the definition of slope. Good luck.